Hello, thank you for tuning in and listening to my presentation. My name is Lukas Arenson and I'm a geotechnical engineer with BGC Engineering in Vancouver in Canada. And in this presentation, I want to talk about the strength and probably more about limitations of rock glacier inventories and the concerns I have with some of the work that has been done recently. Now, why am I interested in rock glaciers and why I'm motivated to give this presentation? Because there has been many rock glacier inventories popping up in recent years. And in addition, there's also the IPA Action Group on rock glacier inventories and kinematics. However, I do see some limitation in how those inventories are used, and often I found that those limitations and how those inventories were developed are not properly acknowledged, which then results in wrong messages being transported using some of those inventories. Now, first of all, I want to mention that I really think that many of these rock glacier inventories are extremely useful. They provide information that has not been available before, and thanks to, I would say, mainly advancements in remote sensing technologies, we now have a much better understanding of where rock glaciers are compared to 20, 30 years ago. However, there are a lot of limitations in order to keep those inventories useful. And first of all, I just want to hammer it in again that rock glaciers are not glaciers. I still do not understand, quite honest, why rock glaciers are included as part of glacier inventories. They should not. A rock glacier is not a glacier, and therefore it should not be part of a rock glacier inventory. I mean, you may also argue, sorry, of a glacier inventory. You could also argue, why are we not including it in landslide inventories? There are a lot of very useful landslide inventories. And why don't we include rock glaciers in a landslide inventory? Because a rock glacier is nothing but a periglacial landslide. It's a creep, it's a mass movement. So I do really want to stress that we need to separate it from glaciers and have their own inventories. But unfortunately, there is still this connotation with glaciers, and I want to briefly touch upon some of those biases. One is that I've seen inventories where people start to compare areas. So I'll see, oh, we have X amount of glaciers in terms of areas, and we have Y amount of rock glacier areas. And then specifically, you compare them over time and look at how rock glacier areas change, or they don't really change, versus glaciers areas. And we all know, due to climate change, glaciers are receding at unprecedented rates, and we see huge shrinkage in glacier areas, but that cannot be compared. And if you then even include a rock glacier in a glacier inventory, your results of how the overall areas of glaciers, now considering rock glacier or glacier for a second, change with time in a watershed will completely be wrong, because you're including something that really doesn't change its area. The same with when you look at the numbers. How often do glaciers split? Specifically small glaciers, we see them splitting quite frequently now as their area is receding rapidly. But that does not happen to a rock glacier. So only because a rock glacier degrades, or the permafrost within a rock glacier degrades, and the rock glacier becomes from active to inactive, or in transitional into relict, it doesn't split. So it's a completely different process, and therefore we cannot compare those numbers, and we should not compare those numbers. The same with the dynamics. The rock glacier dynamic is completely different from a glacier dynamics, and therefore we should not compare them. Otherwise, we're comparing apples with oranges, something that will not benefit anything, because we're not going to get a good picture of glaciers, and we're not going to get an understanding of how rock glaciers change. I've seen area to rock glacier thickness and volume relationships. They should not or must not be used because they are completely wrong. Rock glaciers do not depend on mass balance. They do not respond to immediate climate. They do not have this dynamics, that dynamic response a glacier has. So we cannot use a current climatic indication to tell us how its behavior, how it constituted and how it evolved. For glaciers, we can do that, but not for rock glaciers. And that's why these correlations, which are also probably questionable for glaciers, must simply not be used for rock glaciers because they are completely wrong. And finally, when it comes to hydrological significance and runoff, again, you cannot compare a glacier that is contributing to towards the end of the summer, specifically when a watershed in dry areas may depend on runoff from a glacier, to a rock glacier, which in essence has no runoff because the permafrost is protected, and only when it degrades, it contributes very little to a watershed. So those comparisons should not be done, and that's why when we look at inventories, we may not compare them. So here it's just what I've already mentioned a little bit in wording. So rock glacier numbers really do not change within a measurable period, because how would a rock glacier split? It can't disappear completely. It can only change its state. The only way it can really disappear is if you have additional debris covering it, or a rock slide, or it slides away. But not from a climatic perspective. It can only go from active to being relic. And I also mentioned the immediate climatic control that is not within a rock glacier. The rock glaciers do not immediately react to climate conditions. Typically, we see it in the kinematics, for example, changes in precipitation, or we see increase in unfrozen water content that can change its kinematics, but the latent heat is one of the main aspects that changes the dynamics. And finally, rock glaciers are extremely diverse. Not saying that this diversity does not exist for glaciers, but I found that rock glaciers are much more diverse and are therefore very difficult to delineate, because even optically they may not differentiate from the surrounding terrain, compared to a glacier where you typically have the surface ice and you can differentiate that, at least more or less, ignoring debris covered parts, from the surrounding terrain. There's also the challenge when it comes to INSAR. Again, extremely useful technology, should be used, and I really appreciate what's been done by the working group on developing these guidances. However, we also need to make sure that we know the limitations. So first of all, there's topographic shade. So there's areas where you simply do not see the dynamics. Then we have the terrain aspect sensitivity, and we have the slope sensitivity. So depending on the aspect and the slope, the sensor that is coming down from one angle may or may not see the deformations better or worse, or not at all. And then we also have the challenges with coherence when it comes to winter and snow cover. So some rock glaciers that actually show acceleration during the winter, because that's when the summer heat penetrates, or when some of the infiltration may happen, so you have an increase in unfrozen water content towards the winter, we actually may miss this seasonal acceleration at depth because of coherence issues with the INSAR. And assuming then a linear model, or extrapolating it linearly over the winter time where you do not have good coherence in your INSAR data, may again result in not the accurate dynamic results of these rock glaciers. And finally, we need to make sure that data are analyzed by experienced individuals. So there is a little bit of tendency that you just push a button because computers can do so much and there's so much data out there. But in the end, we want to have professionals that are experienced with this technology to actually use it and apply it. And I just want to go through a couple of examples where we can see these challenges develop. So yeah, how many rock glaciers are there? How will they change in the future? And where it is its dynamics, and you can see we're here a little bit in a bowl. So we have slopes facing in one direction, slopes facing in the other direction. We have a rock glacier coming down here. There's a front, there's a front, there's a front. We get some slope instabilities that you can see through these cracks in this direction. So there's a lot going on here, and how are we assigning a single value that can be used when you start comparing them? It's very important to know that there's a rock glacier. We can probably say there's a lot of ground ice within this particular area, but what you do with this is a different story. Same here. Where exactly is the rock glacier? Is it one rock glacier? Is it two rock glacier? And that's, for example, when we look at the area to thickness correlation. I mean, I can outline this area, I can outline this area, I can outline here smaller areas, or I can put in the whole slope in one area. Now, only because I'm combining some rock glaciers, because they're coming down from a lot of different sources, that would end up in thicknesses being significantly different. So right there, you can see that you should not use the area to conclude on a rock glacier thickness and then its volume. Another important aspect is what constitutes a rock glacier. I know this has been discussed within the working group quite significantly. So here we see this rock glacier creeping down. Here's the front down here. Now, this material here, this all comes from the rock glacier. But I know that the guidelines just would say, okay, let's just limit it to 50 meters and here. However, wouldn't this be constituted as part of the rock glacier? Because morphologically speaking, this material would not be there if it wouldn't be for the rock glacier. Now, is this just a talus slope that is associated to this rock glacier or not? So there's a lot of questions. But when it comes to geohazard, for example, I want to know, because I want to make sure that this unstable slope here is probably an area I want to avoid. There's the potential that there's continual raveling and rock falls coming down these slopes, and there may be rocks ending up at the bottom of the slope because of the activity of this rock glacier. So these are questions that need to be answered, and they need to be considered when I develop an inventory or use the inventory. The same here. A very complex rock glacier system, and I don't think INSAR or any other methodology would really capture the complexity here. And when you look at these little slopes here, yeah, when does a rock glacier really start? So do I count this now as a rock glacier? I don't count it as a rock glacier? What's the thickness? And discussions that again we had in the working group is what's the upper limit of this rock glacier? When does a rock glacier start? And then we have this talus debris coming down here, so it's covering part of the rock glaciers in this very complex dynamical situation. So we've got to be careful, and it's also important to understand that ground ice is not just present in rock glacier. So we should not just focus on rock glacier when it comes to looking at the periglacial environment. As these pictures have shown, there's other landforms out there, and ground ice can be deep, can be buried, can be under talus. It's really important to understand that we should not just bias ourselves to think that ground ice is present in rock glaciers, and that in rock glaciers the ground ice content is high. It doesn't have to be. So it can be actually very limited. I like the analogy that we should not just look at it as if we have a hammer and everything is a nail. So in summary, rock glaciers inventory are useful, I would say, very useful, but they must have a purpose and we must understand their limitation. And we must make sure that rock glacier inventories are independent. So we should not include them in glacier inventories because there are biases if you do that. And it comes to the thickness, it comes to the actual ground ice content, it comes to its dynamics, and finally its number. And I'd like to conclude here with this Keith Haring picture. And not just because of this picture, which I think is very cool, but what actually Ursus Verley is doing, who some of you may know him from Ursus and Nadeshkin. He has a project called Cleaning Up Art. And that's how he looks at a Keith Haring picture. So all the art is nicely cleaned up. However, that's really not what we need to do with the periglacial environment. Just looking at the periglacial environment and the glacial environment in this case, why do we want to put boxes up there in categories and put everything into a specific category? Why can't we just enjoy that this environment is extremely diverse, it's extremely dynamic, and there's all sorts of different colors and forms, as we can see here in this picture, where there are rock glaciers, there are solid fluxion slopes, and there are things that may not have a name. And I'm perfectly happy with not naming everything and not having to clean up this environment and categorize everything just because we need to give everything a name. So thank you very much, and be happy to discuss some of those thoughts during the discussion, or send me an email and we can get in touch. Thank you very much again.